What is up, people? I hope you are good. I've got a laptop here, it's dead, and I've never seen this. This is a Lenovo P1, says it over there, and it's yeah, it's still Thinkpad. Yeah, it's still under Thinkpad, and it's dead. So one thing that I've done, I've taken it apart, not apart as such. I just opened it up and I plugged a charger. There is no response, zero, nothing whatsoever. It doesn't even draw anything. So obviously we won't find any voltages on the motherboard, not at all, nothing at all. So let's just check here by the charging port, make sure that we've got power coming in. Okay, I'll bring the multimeter over there so that you can be able to see as well. There we go, 19.61. So we have already concluded that our charging port is fine. So what I'm gonna do is, these are secondary power rails for the CPU, these ones, and these would be for the GPU or vice versa. I'm not sure which is which. Yeah, VRAMs are over here, so this has to be GPU and that's CPU. And as what I'm gonna do is I'm gonna check these capacitors to see if I've got a short there. If I have a short, then I've got a short in the main power rail. We don't have a short here, so we do not have a short in the main power rail, which hopefully means we've got a dead what is it called, MOSFET. And then I also check around the BIOS. I see that's the second thing that I do, which makes my life much easier. A BIOS chip is supposed to have one ground, so here's a BIOS chip, that's ground, and that's fine. Let's check the other side, that's also fine. So if it's like that, it means we do not have a dead PCH. So yeah, there's quite some stuff for this. Let's take it apart. So I'm gonna pause the video, take the motherboard out, and then resume once it's out. Alright, people, got the motherboard out finally. It was kind of unique to remove, to take apart. It's kind of modular. You can see the USB ports, they come out and they do not look healthy at all. Look at that corrosion. That is some serious corrosion happening here. This thing has been in water. And the funniest thing is that this side I do not see any signs at all. Nothing whatsoever. But this side it's a different story. So let's look at over here. Yeah. Okay, and look at that. This is the worst. I do not think there is life here. I don't think there's life at all over here. So yeah, let me just clean that area first and then we see from there. It might just be something as simple as a cleaning of this area. And then it works. So it might be clear to look at it from that side. So that's the area which had corrosion there. So I've sort of cleaned it up. Now the next thing that would probably work for us would be to add a little bit of flux and heat that area up. That might just be a solution to our problems. Yeah, I'm pretty sure most of you out there have managed to fix a liquid damaged device by just cleaning it up with alcohol and then using flux like this. Because if you look at the components, they don't really look bad. There's just some corrosion there, which probably was causing short circuits where they were not expected. And then this side, what do we have over there? That looks okay. So our power basically comes from around here. We've got too many MOSFETs and too many fuses, so that's probably where our power is coming from. I'm gonna plug that charger again and see how the device behaves. So let's face it. Okay, charger comes over here, and that's pretty much it. Let's plug in the device, and yep, device is plugged in, and still there's no response at all, nothing whatsoever. So let's have a look at the power rails here, just underneath this protective sheet. And there's nothing really, no liquid, nothing. It's just okay. So let me have a look at that fuse over there, because that looks like there's supposed to be is it a fuse or a resistor there? That's a fuse. So yeah, that's definitely a fuse. Let's check if it's still working. Probably the fuse is blown. Funny enough, the fuse still works. The MOSFET is still fine. This other MOSFET, it's still fine. Interesting. So we've got a device over here that's not responding to power. Components seem to be fine. So we most likely have got an issue with our BQ IC, or whichever IC is controlling these two. So let's have a look. 19.5.61 is coming in from the charger into the fuse. It's going out of the fuse into the first MOSFET. Second MOSFET is giving us nothing. So we will definitely have nothing over here. Let me just check if I've got a short right over there, because that might be the reason why we do not have any power and we do not have a short. We obviously don't have a short here because 19 is there. That's fine. There's no short over here, no short circuit. There's no short circuit either over here. So I'm expecting this to link with this here. So basically our power is something like this. We've got two Type-C ports over here and a Lenovo USB charger. So the USB charger, the normal one, comes over here. Fuse, MOSFET, then main power rail. Then the Type-C charging ports, they come from either of the two. Fuse, MOSFET, main power rail, MOSFET, main power rail. So this should be linked to this there, as you can hear, and it should be linked to here. So that's just it. That's pretty much it. Let me plug a Type-C charger and see if we are receiving the precious 20 volts from the Type-C charger on either of the ports. They look really bad, corroded to the max. let's just see if we've got 20 volts getting over here. So let's see over here. 20 volts is coming in from this port over there. Let me check the other fuse. It's got 0, as you can see. So if I change the port and use the second port, we still have got 0. So this probably is where our problem is. Yeah, I've changed, I've flipped the charger around, still we've got 0 volts. Yeah, still we've got 0 volts, so the second one is now also giving me 0 volts. So I got 20 volts for a moment there by the Type-C charging port, but then nothing else. Let me just test it on the phone. Yeah, and it still responds. So the charger is not the issue. No, there's no problem with the charger. I didn't have a ground probe anymore. Yeah, both ports are working. And what we have on our main power, we've got 0. We've got nothing on the main power over here. So it doesn't matter which port we're using, Type-C or USB charger, we do not get 20 volts on the main power. So we need to figure out why we're not getting 20 volts on the main power. So for that, I'm going to continue using our USB charger. And I think this is our PQIC over here. It's pretty clear. Yeah, that's our PQIC, and we need to find pin number 1. We've got 18.1 volts coming in. We're supposed to be getting 20. So yeah, we've got 18.1 coming in. Something is happening that's causing us to get 18.1. We need to find out how it gets here before. I just want to measure around here to see if any of these components that had corrosion would affect our issue. So let's just check over here by these guys. One of them, let me rather use a microscope. Let me see if I can zoom in on this. I can, but it won't be that clear because of the glare. So I'll just pick it up like that and then spray it with alcohol and brush off that flux. Alright, there we go. That's clear enough, I guess. So we are dealing with this over here. So I believe our 20 volts has to be somewhere around here. Just somewhere around these components. I think I can feel some heat. Probably from, oh no, I was heating up the board. I just consider that there is nothing. Okay, there we go, 19.10 volts over here. So you can see got 19.10, but our charger is bringing in 19.5, so it's still kind of low. And then we're getting 18.83 over here. And then this 18.83, how is it getting to be 18.83 here? Because this is the same thing that I'm getting, 18.83. From here, I am getting 19.09. So which of these guys is giving me the 19 volts? So these probably are the ones that are coming from the Type-C. The Type-C ports. Let me remove the charger and go for the Type-C. See what voltage I'll get over there. So let's see. Yes, so there we go, 20 volts. So there we go, 20 volts is coming from this flip over there. So this is where our voltage comes from the charger into this dual diode, and then comes to feed the BQIC over there. But then we're getting 19 from over here, 19.57 now, which is normal. And then on the output, what is the output of this diode? 19.30. And then when I check over here, I've got 19.29, which is quite normal. This BQIC should be active. But then it's not, because when I'm now measuring over here, I've got nothing. Because I should be able to get okay, and then I've got nothing over here. So I should be able to get that 25 volts to activate this MOSFET. So there's nothing over here. So I'm going to make a wild guess and replace that BQIC, because it's kind of close to where the corrosion was before. So let's just take it off, and can you see the number there? BQ24780S. Right. There goes the BQIC. I'm going to pause and find the BQIC we can use, but I don't think I need to pause, because I probably have got one here. But I remember this doesn't use 2.4, it uses 2.5. What number is this? BQ25, yeah. These use 2.5. Let me pause and find the BQIC and then resume. Alright, we've got a BQIC over here. I'm gonna take this one. It has been tampered with. I just hope that it works. I wouldn't worry about that a lot. Okay, cool. That's our BQIC. So just to make things clear, what I'm going to do is I'm going to plug the charger before replacing the BQIC and see what the output is on that diode on this guy over here. Alright, I've got 19.23 coming in. What do we get now? 19.11, and we're getting 19.11 over here. Alright, okay, so that voltage is kind of increased. Remember, before it was 18.83. So let's replace that BQ, which is pin number 1. There's pin number 1, like this. So to make it easy for the BQIC to sit, it will be wise for you to just kind of floor the area with fresh solder. But I'm not gonna do that. Let me sit here like this. Alright, here we go. And there we go, seated. Yeah, that looks fine. That also looks fine. That looks lovely. On this side, that's okay. So I'm gonna plug my charger. See if I get a response from the charger now. Nope. No life, nothing whatsoever. Nothing whatsoever. And we're back to 18.9. 18.93. Why is this not activating? Do we have a short circuit somewhere else? I doubt that. The USB ports kind of had some liquid there, but those should not really affect us because they're quite far. They're quite far off. That's now a secondary power law, and in these models, I believe they would first make 5 volts always, and then convert that to 5 VS, which then goes to the components such as USB ports, etc. So considering that they are way up the food chain, is it way up or way down the food chain? I don't know. I don't know. It's the power chain. They wouldn't really affect power from the charging, because at this point this device is not drawing any current at all. So what I'm going to do is I'm going to force it to draw current. Yes, I will do that. How do I do that? I will go from the 19 volts that I know is over here to right over here, where it gets to be the main power rail, and then see what the response is. It's not drawing anything at all. It did spark, probably because my probe went on to ground, but there was nothing. There was no current draw at all. Let me do that again. Yeah, now I've got 19.662 right on this power rail here, and nothing else. Nothing whatsoever. 0 ohm. Like 0 ohm current draw. 0 amp and then. So yeah, there has to be something else that's happening here. I need to figure that out. That's gonna suck. So I'm gonna pause the video now, try to figure things out over here. Most likely I'm gonna have to reflow this guy over here. I don't know what it is for, so that's why I'm gonna pause the video, try to download a schematic or a board view, have a look at this device, and then resume from there, because I am working blindly. I've never worked on something like this before. Similar models, yeah, but not so direct, because I don't believe that a BQ should be able to control 6 input MOSFETs. I know it controls 2, so probably there has to be someone else who has to control probably these 2 also. So yeah, because remember 20 volts is getting here, so communication between the charger and the board is there. The CC lines are active, the 20 volts main is active. Now the main power, that's the one that's missing. So from the entry point of the power to the main power, that's where we have got an issue. I'm going to pause now and try to figure that out.